As Jeremy said, my name is Greg Richardson. I'm a distinguished engineer and LabVIEW product architect within LabVIEW R&D. Before I get started, my father-in-law spent his career working with the space program. He worked on the guidance system for the Saturn V rocket. But that gives me a little bit of a connection to who I want to talk about here. Margaret Hamilton was the first programmer hired to work on the software for the command module and the lunar module for the Apollo program. So not only was she first, but she also became the lead of that team. And during her time on this project, she coined the phrase that I think we all use. She is credited with being the first to refer to software engineering, because she saw software not being given the credit it was due within the other engineering disciplines. So she started calling it software engineering, and it caught on. So we have the definition of our role ties back to her. All right, so about me. I've been in LabVIEW R&D for over 32 years. These are a random smattering of things I've done. My first project when I started was DDE. Can anyone here besides Brian tell me what DDE stands for?
Dynamic Data Exchange.
Yeah, very good. Dynamic Data Exchange. The code is still in LabVIEW. It's a shame. But it was cool as a new grad. I joined NI in May, directly after, like days after graduation, because I was broke. And I had code that shipped to customers in September of that year. Went on to work on UI things. I created the intensity graph. Had a period where I really got into LabVIEW variants. I worked on BridgeView, which was the predecessor to LabVIEW DSC. I worked on a student edition. Some things that never saw the light of day. I ported LabVIEW to NT running on PowerPC, because we had ported to PowerPC Max, so we had the code generator, and we worked on NT, so I combined them and built it, and we never shipped it. I also had LabVIEW running on Deck Alpha on Windows. Things that never went anywhere. But in things that did go somewhere, I worked on the early versions of the app builder, componentizing the runtime engine. In LabVIEW 5, I worked on DLL building. There was this little hiatus with this thing called NXG. It shipped, though. It did ship. And I was the one who created LabVIEW libs, LabVIEW libraries. Thank you. Back when I thought it was possible to keep a secret, I am the person that came up with the term super secret private special stuff. I did not implement everything that's behind that, but I came up with the word. And in the vein of not being able to keep secrets, Windows long paths, another config token, set it to true. It's been in there since LabVIEW 2021 SP1, and lets you use paths longer than 255 characters on Windows. So this is another thing I've been doing recently, is kind of doing proof of concepts and then leaving someone else to productize it. And so I think this is finally going to get productized soon. But a little bit about me. So this is kind of my agenda. Elements of a modern development workflow. You may see that this is kind of process focused. And I think that is a lot of the things that come from the idea of the modern workflow, is having all this automation to do a lot of the work for you. Having a good pre-commit validation scheme to make sure that you're not introducing problems. And then that goes, retesting after things are committed. And another important piece here is that export creation. It's not just testing, but it's actually building whatever it is you're going to pass on to the next set of clients. So, getting into some of these things. Machine setup. And yeah, this is going to be kind of broad in many cases. There are some tidbits that are more specific. I think every person in here will learn something they didn't know before, even the NI people. If you get to the end of this presentation and you don't feel like you learned anything, find me later and tell me, because I'd be surprised. But anyway, so when you're talking about machine setup, there's developer machine setup. You want to make it as easy as possible for them to get up and running. But then there's also the agent setup for all your automated tasks. How do you make it easy to spin new agents up? And how do you make sure that your agents are stable? They're not introducing problems into your build. So one of the questions there, particularly on the automation side, is how much is in your base image versus how much is dynamically created for the build? And the things to think about there are like, how frequently does this component change? For some people, if you're tied to a specific version of LabVIEW, you may be fine with just pre-installing LabVIEW on all your build agents, because you hardly ever change it. But if you have to build for different versions of LabVIEW, you may want to make that more dynamic. You can just install all of them, but it can help to allow the build to decide which version it needs. Now, in order to do that efficiently, you probably don't want to run the NIPM installer every time. It's a little slow, we know that. But there are people who are having good luck with using containers, putting LabVIEW in containers. Some of the key things to think about there are licensing, if you're dealing with Windows, because we don't have the capability to cross-compile or cross-build for other desktop targets, so you can't run a Windows LabVIEW and build Linux binaries. You can build Linux RT binaries, but not Linux desktop binaries. That's another area that we hope to change at some point. But right now, you have to use the OS that you plan to distribute for. And so if you have a Windows container, there is a way to automate the activation of the license. I have links in here. These slides I will make sure are available afterwards so you can follow them. But there is an answer for that. Also here, our deal to ship JKI Dragon with LabVIEW, to me, is a big deal in this space, because it can automate installing dependencies, even LabVIEW itself. Source control. So a lot of people think of source control as, okay, if you have a team of more than one person, you need source control so they can collaborate. Source control is about a lot more than that. I'd say if you built a VI that you would be upset if it was gone, then you need source control. So source control is about backup. It's about history. Source control is a time machine to go back and look at what things looked like before. It's about release management. And since in our current world, a lot of source control is done online, in the cloud, it also encompasses some of the other parts of your workflow, like code review. So that's very convenient. Now, specific to LabVIEW, it is very important that you commit frequently and make small commits. Diffing in LabVIEW is not the same as diffing in a textual language, where we're trying to make it as smooth as possible, but it is different. And making smaller commits decreases the chances of conflicts and also makes it easier to understand those changes when they go in. If you're not using separate compiled code, that must be painful for you. Don't do that. You always want to separate compiled code. You don't want to deal with all the changes from recompiling and it decreases the size of your repo. In 2024 Q3, the release that is live now, we also have the project save version. So if you need to support some customer using LabVIEW 2021, you can still run the latest editor, tell your project to save all your files as LabVIEW 2021, and so all your source stays compatible. But you get the benefit of all the latest editor functionality. You still have to do your builds in that old version, but that's just your build agents that are running the old one. All your developers can run the new one. Merging, let's face it, we'll admit it, merging in LabVIEW is not good. Best bet, avoid it. So modularity is an important part of that, and communication between your team of who's working on what can really help, and making your VIs as small as possible. And then another fun one is your builds do not submit to source control. Build output does not belong in source control. It is your output, not your source. Literally, it's not source. So don't put your built output in source control. Use another system for that. I'll talk more about that in a little bit. Also related to source control, branching model. I am a firm believer in the mainline branching model. So there is one main line that is always your development branch. Changes get submitted to there, and then you branch off of that for releases. If you need to patch a release, you first submit the fix into the main line and then cherry pick it to whichever release branch you're patching. If you're not familiar with this, I encourage you to go find resources about it. It's well talked about on the internet, but yeah, for any kind of development, I'm a firm believer in it. Code review. As I said, GitHub, ASDO, GitLabs all have their pull request UI. A lot of people prefer to do in-person, code reviews with the author, which is definitely viable. You can also have your reviewer do an interactive diff in LabVIEW without the author. Within NI, we are gravitating more and more toward having automated tooling that can generate diff reports and put them into the PR itself. So in the LabVIEW code base, we have an extra pipeline that you can just tell to run, and it'll go through and run a diff on all the changed VIs, include that description as well as pictures of the diagrams into the pull request, so the user doesn't have to leave the PR tooling to see what changed. That tooling I'm talking about right now is not available externally. Another thing we're looking at. But there are options. You can manually generate a diff report. So the author could bring up the interactive diff, and I've shown the menu down here where there's a create report option that can create a web page, plain text, or a Word document, and then somehow associate that with the pull request. They could just put it up somewhere and put a link to it in the pull request. You could copy and paste it directly in, but it really makes it a lot easier to for the reviewer to see what changed. And then, of course, you can automate that. There's this VI that's in vi.lib, SEC sup compare two VIs, that can programmatically generate a report. Unfortunately, that's not the kind of report that's the most useful, because it doesn't support these options over here. It just gives a different textual representation of the diff. Back to that not keeping secrets thing, If you have super secret private special stuff turned on, there's an application method under the user interaction category called compare VI's XML. And that method exposes the ability to generate all these reports programmatically. And then for our PR tooling, we use a combination of that with printing to get the pictures of the entire diagram. So they aren't annotated with the diff highlighting of the objects that change. This is just a full picture, but it works pretty well. All right, dependency management. As I said, just like your built output is not source, your dependencies are not source. Your list of dependencies is source. That's something you came up with. The dependencies themselves are not yours. They shouldn't be part of your source control. So you need some other content management system to get these. In many cases, NIPM or VIPM can be that because you're depending on community add-ons that are available that way. And JKI Dragon is a great way to automate that. But you may also want to invest in some other artifact management system. NI is just finishing up a migration to JFrog Artifactory for all of our build artifacts. But the main thing is, treat that as a separate piece from getting your source. And for automated systems, it's important that you know that you can rely on those dependencies being accurate. You don't want one build to get a different version of a dependency and then a later build to use that incorrectly. One of the things that helps with that is having your dependencies in a location that can be easily cleaned. If you're installing your dependencies into the LabVIEW directory and you're wanting to keep LabVIEW but clean out all the dependencies, that's difficult. So don't do that. There are multiple ways, multiple alternatives. How many people are familiar with LV add-ons or version-independent add-ons? Wow. Okay. We got to work on getting more people in the know about this. But yes, if you've installed versions of LabVIEW 2023 or 2024, you'll see that most of our drivers no longer install into the LabVIEW directory. They install into C program files, NI, LV add-ons. And so those add-ons can then be used by multiple versions of LabVIEW. Well, if you're trying to isolate your dependencies, you might want to override that location and pick a new location and tell LabVIEW, this is the only place you can look for add-ons. Anything that got installed into the standard location, ignore that. This is the only place I want you to look, because that's where I'm going to put the ones that are appropriate for the project I'm building right now. So this LV add-ons.custom location is a config token to do that. In 2024 Q1, there's a second config token called additional locations. So instead of just being a single location that you can override, this is actually additive. So if I want to use the standard installed add-ons plus have some more, I can use this. We actually use that internally. We have some developer add-ons that we use that we point at an extra directory like this. So they're available to us. And that is a semicolon delimited list of paths. You can add as many as you want. They all just virtually act as overlays onto the add-ons directory. So all those add-ons are considered together. A different approach is this library paths config token, which has existed a little bit longer. It goes back to 2021 SP1. And it, instead of kind of dealing with the LV add-ons directory, it deals with the LabVIEW directory itself. It acts as an overlay to the LabVIEW directory. So everything in your directory, if you have a vi.lib in your directory or user.lib, that acts just like you had put it into LabVIEW's user.lib. This is target specific, so you can define one for localhost, which is whatever your desktop that you're running on is. And then for RT, you have to cover two bases. Our PXI RT devices use a different config token than our CDEC RT devices, but if you just set them both to the same place, they're both Linux RT, so in general, that's fine. So a different way of isolating your dependencies on a build so that they are easily cleanable and you can start fresh for the next build. Build output locations. So in prepping for this, I went back and watched some old presentations, including Darren's presentation from 2 years ago on 7 ludicrous ways to fix broken VIs in LabVIEW. And one of the things he said was, always build your PPLs to C:\PPLs. The thinking is not wrong, but if you have something in C:\PPLs and you have a VI that references it that's still on the C drive, then it's going to reference that with a relative path. So then if you move that VI one level deeper, then the paths are messed up. So a better way, perhaps, to do that is making sure you're using a pseudopath. In this case, I'm suggesting using user.lib. And we can go back to the things I just mentioned in the last slide about controlling some of these locations to define where that goes. So if I set an add-on location as of C:\add-ons, then I can create a PPL add-on, so to speak, which just requires making the directory and creating an LV add-on info.json. And then I can have a user.lib in there, and everything I put in there will be seen as being in user.lib by LabVIEW. So I can build everything to there, and they'll all be referenced by a consistent pseudopath that will travel across machines and travel between projects without any problems. This can actually be extended for platform and bitness within the LabVIEW directory, there's targets, NI, RT. And so you can create that same hierarchy within your add-on, and it does the same thing. On RT devices, this will be another user.lib location that it will use. Starting in LabVIEW 2023 Q3, we also extended this to support the desktop platforms. So in any LV add-on, you can create these target Win32, Win64, and Linux directories. And if you're distributing PPLs that have to be built separately for each platform, put them inside these directories, and LabVIEW will automatically use the appropriate one. So that's a big help. Got a question? Yes.
So I like this idea. I was not aware of this. Seems pretty powerful. Is there more information or documentation on what needs to go into that JSON file to make this work?
Part of the reason that so few people raised their hands when I said who knows about LV add-ons is because we have done a poor job of creating white papers or documenting it. So there is no good external documentation on what goes into that JSON file, but if you have LV add-ons, open up a couple of them, and it's not too complicated. There's a name, there's an earliest supported LabVIEW version, and then there's an optional thing for bitness, and that's pretty much it. So just copy one and modify it. All right. Yep, that's it there. So, again, that third option for controlling locations is this library paths concept. This could also be used for this PPL build output location. So you could use different paths for the local host and the RT targets. Or again, you could set all of them the same, set them all to C:\PPLs, and then use the target directories within that for the platform-specific PPLs. All right. Static analysis. You should do checking to validate that your submissions are matching whatever policies you have in place. I would suggest that, checking that it's saved in the right version of LabVIEW, checking that things are source only or separate compiled code, checking for broken VIs. If you have a policy on connector panes, validate that the connector panes are using the right pattern. You may go to things like VI complexity, run the VI metrics on it and complain if someone's submitting a VI that's too big. The main thing is, define what you want to be enforced and then find a way to enforce that. VI Analyzer is probably the most common way of doing this. There are tons of VI Analyzer plugins to validate all kinds of things available. You can also write your own. So its abilities are very broad. It means running LabVIEW. Some people don't like that. They want really quick checks. So there's this other thing called PyLabVIEW, which is a Python project, open source, that parses LabVIEW file formats. They've reversed engineered our formats. And it can't do as much as VI Analyzer, but what it does very quickly. It can do things like checking the editor version, checking for source only. It can't check for bad VIs because you can't trust the state of the VI on disk. Again, this is not made by NI, but it is used by NI. So we have a vested interest in keeping it working. So don't be scared off by the fact that we didn't create it. I would expect it to stay working. All right, testing. Main thing here is don't build your own test framework. Try not to, really. There's plenty of them out there. Karaya is very popular. NI has our unit test framework. You can use that. The basic concept for all of them is you define your unit tests, which is basically defining some inputs that are going to be sent to the VI and the expected outputs. The framework takes care of loading it, running it, comparing the outputs, generating a reasonable report on what happened. That's all work that you don't need to replicate. So do that, integrate it into your builds, generate your reports. Then automation mechanism. When you are trying to get LabVIEW to do something, you can just launch LabVIEW and pass command line parameters to make it do things. Don't do that. For automated systems, use one of the CLIs. I don't care if you use NIs or if you use gCLI, but use one of them. These things were created to work better from the command line. So they deal with standard out and standard error. They were created to work headlessly. So they do all the things to make LabVIEW try to behave as good as possible in an automated environment. And as we make improvements to make LabVIEW work better in those environments, it's these CLIs that we're going to make sure keep taking advantage of that and use it optimally. So if you're already using this, you'll get all that for free as LabVIEW evolves. And then they also can separate the operation lifetime from the LabVIEW lifetime. So launching LabVIEW, takes a little bit of time. If you're trying to make your build as fast as possible, you don't want to have to keep relaunching it. So with the CLIs, you can launch it once. Each operation is atomic, but LabVIEW keeps running in between. So just quick show of hands. How many people here use the gCLI? Okay, a number, but I would hope it would be higher. Do we have people here that use the LabVIEW CLI? Okay, some of the same hands, but all right, there was some difference. Okay, and that's it, but I definitely welcome questions and comments. Derek? What have I missed? Think about this. What other parts of the development workflow should we be talking about that I didn't have up here? Okay,
All right,
Derek.
I've got a list. You're going to have to cut me off.
Okay.
I'll start with the first one, and I'll bug you for the rest later, probably. How can you install stuff to other LV add-on locations? So if you want to use that, everything's built into NIPM, and they're installing to specific locations. So I don't imagine that's an easy process.
There's no clean answer.
Okay.
I believe there is actually a registry key you could monk with that would tell NIPM to use something else.
So basically use it for your own custom stuff, but it's not really some of the standard install stuff you can't cleanly separate still.
It's more difficult.
Okay.
Yes.
I'm going to ask one more question if anybody
Sure.
else doesn't mind.
Go for it.
So one of your slides mentioned resolving symbolic paths and saving dependencies as symbolic paths. There's nothing public to do symbolic path resolution?
Good question. And actually, there is. At least since LV add-ons were introduced, there are VIs in vi.lib under utility symbolic paths, I think, that really need to be added to the palette and haven't been. But there's VIs in there to resolve symbolic paths, and you can ask for a single resolution, or you can actually have it pass back all the possibilities. So one thing you can do just to see what paths are being used by your LabVIEW is use those VIs to resolve the symbolic path libdir, which equates to the LabVIEW directory. And you depending on how many things you have installed, you may be surprised by how long that list is. But it'll tell you exactly which add-ons LabVIEW is using.
Well, one thing I think you've missed in the workflow is documentation. It is part of the entire workflow. How do you document stuff using anti-doc or something like that?
Yeah, documentation is an excellent point, and you may have just pointed out a weak point in our process. But yes, absolutely. You want to make sure that your documentation is getting kept up to date. For LabVIEW, for our design documentation, we include it in our repository. So we use an ASDO source control backed wiki. And so documentation updates are part of the submission of the code. So it can be reviewed alongside the code. It can be pointed out by a reviewer that, hey, you're not updating this document at the same time. But that's for our internal documentation. Our external documentation is handled differently. It has its own content management system that it uses. But that's definitely another consideration.
Just to make sure I got that right, Greg, the add-ons path is a symbolic path that works like VILib, for example, with the difference that it installs once on the machine and not for each LabVIEW version. But it resolves in the same way that VILib would resolve.
Yeah. Each individual add-on directory. So the structure of this is, the base add-ons directory, the name of the some name of the add-on, and then a version directory, and then that next directory acts like an overlay of the LabVIEW directory. So it can have things like resource, user.lib, vi.lib at that level. And yeah, they all just act like they were in the LabVIEW directory from the beginning.
So if on my computer I have something in the regular VI lib, and then my colleague opens the same VI and he has some add-ons directory-based VI lib, that would work?
Yes. As if you have something at that path underneath vi.lib, it would resolve whichever one it was in.
And if he has both on his machine?
If he has both, then you get into an ordering issue. And that's another place where doing that resolve of just libdir is informative, because it's also showing you the order that LabVIEW is using those.
But by the time I run that VI, it's too late because LabVIEW already has loaded something, right?
Well, you can run that VI to figure out what LabVIEW is going to do and see if it's what you want or not.
Okay, so I can at least check if it did what I wanted it to.
Right. You can double check that it's in the order, that it's going to find it in the order you want, and if it's not, then you can shut down LabVIEW and go fix up your file system and relaunch.
And do you think that there's going to be some guidance from NI in the future on how to use all these things? And if so, by when?
Deadlines, come on, I'm a software engineer. I don't do deadlines. Yeah, I mean, it needs to be documented. It's on the backlog.
Yeah, I can project. Yeah, the question is, when you were showing all the tricks to use the LabVIEW compare, is there any plans on creating something that makes it easier to actually connect or call from Git? Because every time that we figure out a batch or a way to make it work, I have to go update the blog post because it breaks eventually. So
Yeah.
and it's not only LabVIEW's fault, it's not NI's fault,
Right.
it's also that the tools makers change how they call the different tools, and that breaks what used to work in previous versions.
So yeah, what I envision is that we can create some tooling to help generate these reports. But then the piece to connect that report that you've generated to a particular pull request system is unique to that system. What I'd kind of like to see is for those pieces at least to be open source. And so we'd have an open source project for GitHub, for GitLab, for ASDO.
And then for the multiple clients that we use, the fork and all that stuff. Yeah.
Yeah.
It would be great if that was one of the open source things that you did.
Yeah.
And then my other comment is, NI is also a member of the community. And I understand that NI has to follow product release processes for documentation and stuff like that. It would be great if you could talk to NI and be like, you know, we have to do the formal documentation, and I agree, but I could go to the LabVIEW wiki, like I, as in Greg, go and put these paths on the LabVIEW wiki as interim, and then when the formal documentation comes, you could just add a link to say, hey, the latest documentation is over here. But it would be something that will help us find out about those things, help you make it public. And if your process takes 6 months, well, we'll be 6 months ahead of it.
Yeah, excellent point. I agree. We do not take full advantage of the LabVIEW wiki. And that's an excellent point. Yeah, Aaron?
So on the, I think it was the next slide or the one after that, when we're going back to talking about like the LabVIEW add-on paths, does that now give us the ability to specify dynamic or relative paths in our build specs? Because a problem I'm having with my colleague is the paths we normally use, he's always on the C drive, I'm always on my F drive, and as far as I'm aware, LabVIEW only supports, in terms of build output directories, fully qualified paths? Or has that changed and I'm wrong?
I am not sure, but I would not be surprised that, yeah, the build spec would not support pseudopaths or symbolic paths.
If your build location is 2 directories or fewer, then it will build relative. If it's more than 2 directories, then it will hard code it. 2 directories.
Relative paths on GDevCon.
And it's in the XML. You can find where it.
Yeah.
If you're on the same drive, IG relative paths on VIPM will go more than one level up. But it has to be at least one common folder on the same drive.
Yeah.
The built-in undocumented feature is 2 paths is relative, anything else is not.
Yeah, that's specific to the build output directory. Yeah, you know, it is visible in the XML. You can, if you have to, modify the project before you load it to do the build. I did some playing with the ability to modify the build output path in a pre-build hook. Build specs support having a pre-build VI. Unfortunately, it doesn't work right now. So that's something else that I'd like to see us fix in the future, so that you could have your VI set that path dynamically as the build's starting. But currently, the best answer is to build into your process, modifying the XML if you have to.
I had a question about the system configuration or the dependency management stuff that you talked about. So we'll often take advantage of VIPCs and NI packages. For the stuff that doesn't fall under those buckets like you mentioned, like having another tool to kind of manage those dependencies, I will admit that there are often times where it's just like there's a small installer that I need to do to get a DLL from the third-party manufacturer or something, and I'll put it in source code control alongside, because I don't want to have to manage another thing there. Can you talk about sort of the trade-offs there? Like, do you have a hard and fast rule as far as don't ever do that, and why if you do? Or is it just kind of depend?
I guess I'll connect this to another software engineering concept dealing with componentization, which is a component should have, one and only one reason to change. And to me, this applies to dependencies. If I need to update a dependency, I shouldn't be changing my code. I should be updating something that is that dependency. So within our build system at NI, we have what we refer to as ad hoc exports, which basically just means they are exports that don't have a build process. They're just some files that we put into an export. So you still retrieve that using the same mechanism you would for any other export, but there's no build to create it. When you have to update it, you just manually create a new one with the new files in it. So you might have one person run that installer, capture the binaries, and then just put them up as a new export. So that's what I find to be best practice, and it keeps that isolation from your real source code. We actually have a rule that within our repo, you cannot submit a DLL. The Git rules are set up to not allow it, to help make sure we don't ever do that.
I got a question about LabVIEW CLI. Right now, I've got multiple projects, and I basically launch CLI, build the apps, close CLI between each project. But you said we can leave it open. Are there any cache issues with doing that?
The LabVIEW CLI still launches LabVIEW as a separate process. So the CLI will complete, but LabVIEW can stay running.
Right.
There can be, particularly dealing with 32-bit LabVIEW, there can be memory fragmentation issues that build up over time. So yeah, right now, if you're doing a whole lot of builds on 32-bit, you may want to shut it down, every 10 builds or something. Just depends on how many steps you're doing within a single build. I would say that, with one pipeline or one, overall build step, it should definitely shut down LabVIEW at the end to leave the machine in a clean state for the next build. But within a build, if you're doing multiple steps, yeah, there could be fragmentation issues, or if you're having to modify the add-ons between builds, between steps, you'd want to shut down LabVIEW and relaunch it then, but it's kind of up to you.
Okay, but between different projects, it's okay to just not have the shutdown in CLI?
Yeah,
Or LabVIEW?
should be.
Okay, thanks.
I have a question. I've been playing around and trying to get Docker working, and it is quite a challenge, and there's not a lot of resources out there. Does NI have any thoughts on putting together some sort of resources or Docker files or examples that we could potentially pick up and actually make work without jumping through a lot of hoops?
This slide does have links to some information about that. There are people that have been successful with it. We were working on an updated white paper, and it is not ready, unfortunately. So one of the resources that is out there is written by a current NI employee, Chris Stryker, who wrote it when he was not an NI employee, but it's got some good stuff in it.
All right, last question.
Last question.
On the Project Explorer for save as previous versions, if I'm using a new version and I save as previous, how would I know if I'm using a feature that's not available in the old version? When would that error show up?
When you're using that feature, there's an extra glyph that shows up in the state panel showing which version it's going to save to. If you use a feature that's not supported in that version, the glyph will immediately turn into something with a warning, and you can click on it, and it shows a new category in the error window to tell you what you're using that doesn't work. If you do that and save, it will save in a version that maintains that functionality. So we don't lose it, but you're now not honoring the save version. So you need to remove that functionality and resave, and then it will be back in the version you requested. But yeah, it gives you feedback directly in the editor. Okay, so that's the last question. That's what I got. I'll be around. If you want to talk more about this, feel free to grab me. And I'm going to put in one other plug. One of my NI colleagues, Sergio, is here. If you want to talk open source, find Sergio. What's your favorite thing that you'd like to see open sourced? He'll listen to you.
The robotics module.
The robotics module. Never heard of it. I don't think we ever made that. Anyway, thank you.